So this is the second video of these three applications I'm going to give you. On homework, I'd like you to pick two of the applications and learn how to do each of the two. And I'll test you on an exam. I'll give you enough choice that one of those problems will be one of the ones that you study. So in your group tomorrow, I'll have three groups in class, and we'll have a temperature group, we'll have a chemical balancing group, that's the third video, and we'll have a traffic flow group, and join one of those groups and work on those problems. Okay, so this one is temperature equilibrium. What is the problem? We got 4 wires, looks a lot like the grid in the last time, but they can be different configuration than this, just this. There can be more wires, some of them can be diagonal and so on. But this is a simple example, example 2 from 1.3, so you can look at it. So here's the idea, that at each end of the wire, you hold this at a particular temperature. So in this case, 20 degrees. The next one is a chilly little 8. 4, 32, 52, 56, 36, and 48. And so those nodes are all held at that temperature. But the wires intersect. And so the problem is to find what the temperature is at these nodes after the entire system stabilizes. Here's how to do it. You average at the nodes. So that means that at node 1, for example, the temperature at node 1 at equilibrium will be the average of the 4 nodes that are adjacent to it. And the nodes that are adjacent to it are the 20, the T2, the T4, and the 48. So the temperature at T1 will be the average of those 4. And so it will be the 20 plus the T2 plus the 48 plus T4. So there is going to be the formula for the temperature at T1. It will be the average of the temperatures at the surrounding nodes. And the same thing will be true for all of them. So the temperature at T2 will be the average of its surrounding nodes, T1 and 8 and 4 and T3, and so it goes. T3 and T4 will be the average of the nodes that surround them. Once you get those, then we'll simplify this. So multiply both sides by 4. So the first equation will be 4T1. Bring the T2 to the other side, minus T2. There aren't any T3s, but there is a minus T4. And that will be equal to 20 and 48, 68. So this will be the first of your equations. The second one will be minus T1 plus 4T2 minus T4 equals 12. And you'll get 2 other equations like this. Then set up the augmented coefficient matrix, the AC matrix. Type it into Mathematica, row reduce, and read off the solution. And if you look at the Mathematica sheet that I gave you, it's got the Mathematica work for that. So this is the temperature equilibrium problem. These set up pretty easily, very similar to the last one, but a little different in how you compute. And I'll send you one more. Thanks a lot. See you soon.